Hello and welcome back to this wonderful channel called Physics Man, your one-stop solution for everything related to physics. If you haven't subscribed to this channel yet, please do so and press the bell icon so that you don't miss any update. And if you like this video, give me a thumbs up. It means a lot to me. And in this video, I'm trying a new scene transition. Give me a feedback about that in the comment section. Now, without any further ado, let's continue with our read along, NCERT read along of chapter number 1, Electric Charges and Fields. A quick recap of what we have been learning till now. We have learned that there are two kinds of charges, positive and negative. We have learned about static electricity or frictional electricity, wherein charges are transferred from one body to another due to friction or rubbing of surfaces. We have learned about conduction, charging by conduction and charging by induction. Also, we have learned about electroscopes, which are devices used to detect electric charges. In this video, we're going to learn about basic properties of electric charge. We have seen that there are two types of charges, namely positive and negative, and their effects tend to cancel each other. Here we shall now describe some other properties of the electric charge. If the sizes of the charged bodies are very small as compared to the distances between them, we treat them as point charges. We have seen something of similar kind in class 11, where we said that if an object is moving and the distance moved by the object is large compared to its own dimensions, then we can treat them as point objects. All the charge content of the body is assumed to be concentrated at one point in space. We have seen a similar kind of thing in class 11 where we talked about center of masses. Center of mass is a point where the entire mass of the object seems to be concentrated or can be treated to be concentrated. But remember here, center of charge is only possible for point charges. That means if the charged body, if the dimensions of the charged body is small compared to the distance between the two charged bodies. If the size of the charged body is large compared to the distance between the two charged bodies, then we cannot treat them as point charges and we cannot talk about center of charges. But in case of masses, we can consider center of mass in such case also. Additivity of charges. We have not as yet given a quantitative definition of a charge. We shall follow it up in the next section. We shall tentatively assume that this can be done and proceed. If a system contains 2 point charges Q1 and Q2, the total charge of the system is obtained simply by adding algebraically Q1 and Q2. That is, the charges add up like real numbers or they are scalars like the mass of an object. What they are saying is we have not defined what is a charge or we have not told the unit of charge is coulomb or anything of that sort. We have just told that there is positive charge and negative charge. Okay, how much positive charge, how much negative charge, we have not discussed yet, but we will understand that we can say we can give some magnitude to the charges. So they are saying, let's say there is Q1 charge and Q2 charge in a system, 2 point charges Q1 and Q2. Then the total charge of the system is obtained simply by adding algebraically Q1 and Q2. So you just have to add Q1 and Q2 to get the total charge. This is the same thing that we have done in class 11 for system of particles. You remember there is a chapter of system of particles and rotational mechanics. There we have said that if different point objects are there of masses m1, m2, m3, etc., then we can find the total mass by just adding m1, m2, m3, etc., mn. That same logic is applicable here also. If a system contains n charges q1, q2, q3, etc., qn, then the total charge of the system is q1 plus q2 plus q3 plus so on plus qn. The charge has magnitude but no direction, similar to the mass. So clearly charge is a scalar quantity because it has magnitude but no direction. However, there is one difference between mass and charge. This is very important. Mass of a body is always positive. whereas charge can be either positive or negative. So when you're adding it algebraically, you have to take care of the sign. Proper signs have to be used while adding the charges in a system. Proper signs have to be used while adding the charges in a system. For example, the total charge of a system containing 5 charges plus 1 plus 2 minus 3 plus 4 minus 5 in some arbitrary units. Maybe it's some multiple of coulombs. It can be microcoulombs, it can be anything. So we have not defined the units, so we'll just take it as arbitrary unit. So what will be the total charge? It will be just sum of these quantities. That will be plus 1 plus 2 plus minus 3 plus 4 plus minus 5. That's what they have shown. And if you add up these things, you will get it as minus 1 in the arbitrary or in the same unit. Charge is conserved. Charge is conserved. We have already hinted to the fact that when bodies are charged by rubbing, there is transfer of electrons from one body to the other. No new charges are either created or destroyed. We have discussed this in the previous videos. When charging by rubbing or the frictional electricity that I was talking about, in that case, electrons jump from one body to the other. So what happens is one body gets positively charged, the other one gets negatively charged, but the total charge still remains zero. So charge is neither created nor destroyed, but charged bodies can be created. Earlier, both the bodies were neutral, but now one is positively charged and the other one is negatively charged. But charges are not created nor destroyed. A picture of particles of electric charge enables us to understand the idea of conservation of charge. When we rub two bodies, what one body gains in charge, the other body loses. If one body gets positive 2 charge, then the other body loses 2 charge. That means it becomes negative 2 charge. Within an isolated system consisting of many charged bodies, due to interaction among the bodies, charges may get redistributed, but it is found that the total charge of the isolated system is always conserved. Okay, total charge is always conserved. Okay, so conservation of charge has been established experimentally. So experimentally also this has been proved. It is not possible to create or destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed in the process. Okay, so you see, the charge carrying particles may be created or destroyed. That means a proton can be destroyed, a neutron, an electron can be destroyed, that kind of thing. So sometimes nature creates charged particles. For example, a neutron turns into a proton and an electron. Okay, a neutron which lies in the nucleus, it can be converted to a proton and an electron. Okay, in some nuclear reactions, you can see that electrons are coming out of the nucleus. So we have already learned you might have already learned in chemistry and in physics that electrons are revolving in the orbits outside the nucleus. Then how can nucleus produce electrons? It's by such a process. Neutron turns itself into a proton and an electron. But the net charge will still be zero. Earlier it was a neutron, so net charge was zero. So now it has become a proton and an electron, and we know that the charge of a proton is plus E and charge of an electron is minus E. So it will get cancelled. The proton and electron thus created have equal and opposite charges, and the total charge is zero before and after the creation. Okay, so that's all for today. We'll continue from here in the next video. Until we meet again, it's goodbye from me and happy physicsing.